Bismillah Rahman Rahim. Continue with thermal analysis. Already we have discussed various techniques of thermal like thermogravimetric analysis, differential thermal analysis, differential scanning calorimetry, dynamic mechanical analysis, thermomechanical analysis, thermometric titration. We already discussed the various aspects of thermogravimetric analysis TGA, differential thermal analysis DTA, differential scanning calorimetry DSC. In this lecture, we will discuss about the aspects of dynamic mechanical analysis. In this technique, we will discuss the principle, instrumentation, and its application in daily life industry. In DMA, it is the most important thermal analysis technique alongside the well-established DSC and TGA, because DSC and TGA are versatile techniques which are used routinely in quality control labs and in our industry. The industry may be of a chemical industry, pharmaceutical industry, or the food industry. DMA allows you to determine modulus values and measures relaxation effects that often cannot be detected by DSC. This is the advantage of DMA over DSC. Depending on the measurement, moment determines either the shear modulus G or Young modulus E. Now we will discuss the principle of the DMA. DMA is used to study the viscoelastic properties and behavior of a wide range of material as a function of temperature or frequency. Since this technique is also comes under the heading of thermoanalytical techniques, so again the material of the function is discussed as a function of temperature or frequency. DMA helps to ensure that the suitable material with the right mechanical properties are used. Dynamic mechanical analysis is most important technique in thermal analysis. The types of material that can be analyzed include thermoplastics, thermosets, elastomers, adhesives. While the thermoplastics is a material, usually a plastic polymer, which becomes more softer when heated and harder when it is cooled. These type of material can be cooled or heated several times without any change in their chemistry. While the thermosets is a type of polymer that is irreversibly hardened by curring from a soft solid material. As well, the elastomer is also a polymer type with viscoelasticity and has very weak intermolecular forces, generally low Young's modulus and high failure strengths compared with other materials. DNA analysis can also be performed for the paints and lacquers, films and fibers, and various type of composites, foodstuffs, pharmaceutical, fats and oil analysis, ceramics, construction materials, and metal analysis. DNA provides quantitative and qualitative information on these aspects. Quantitative is how much and qualitative is what is. The qualitative and quantitative information can be obtained by you on these characteristics of the polymer, like damping characteristics and viscoelastic behavior, polymer structure and morphology. Morphology is a form structure of any material. Primary and secondary relaxation behavior, crystallization processes, influence of fillers in polymers. Fillers are usually used in polymers to enhance the properties of the polymers. In DMA, the sample is subject to a periodic stress in one of several different modes of deformation. The deformation may be a bending, tension, shear, or compression. Modulus as a function of time or temperature is measured and provide information of phase transition. The phase transition is all the people are familiar with the phase transition in our early lectures on thermal analysis. A DMA technology is the perfect solution when maximum accuracy is required and the material has to be characterized over a wide range of stiffness and or frequency. DMA technology is extremely versatile and therefore DMA can characterize material even in liquids or at specific relative humidity levels. Types of dynamic experiments. There are three types of dynamic experiment when we do the DMA analysis of any material. These dynamic experiments are temperature sweep, time scan, frequency scans. When we are talking about the temperature sweep, the frequency and amplitude of oscillating stress is held constant while the temperature is increased. The result of temperature sweeps are displayed as storage and loss moduli as well as the T delta as in of temperature. The T delta will be discussed in next slides. Now the time scan is another way of analysis of a way of experiment in DMA. The temperature of the sample is held constant and the properties is measured as a function of time. This experiment is commonly used when studying curing of thermosets, material that change chemically upon heating. Data is represented graphically using modulus as a function of time. Curing profile can be derived from this information. Now the frequency scan is another dynamic experiment. It tests a range of frequency at a constant temperature to analyze the effect of change in frequency on temperature driven changes in the material. This type of experiment is typically run on fluids or polymer melts. The results are displayed as modulus and viscosity as a function of log frequency. The terminology used in this slide, modulus, damping, T delta, will be discussed in next coming slides. Now we start with the instrumentation of DMA. This is a block diagram in which a force generator at the top of the block diagram, LVDT, this is a detector, thermocouple is also a temperature sensor. We already discussed in former three techniques the role of thermocouples in thermal analysis. The other is probe, and the next one is furnace that is utilized for the heating purpose, while the sample is placed at the ground of the in this furnace. In the instrumentation, the sample is clamped into a frame and is heated by a furnace. The sample is in the furnace is applied the stress from the force generated via probe. To make the strain amplitude constant, the stress is applied as the sinusoidal force. The instrumentation is continued. The deformation amount generated by the sinusoidal force is detected. The viscoelastic values such as elasticity and the viscosity is calculated from the applied stress and the strain and plotted as a function of temperature or time. Against the temperature and time is used in all types of thermal analysis. This is basically basics of any kind of thermal analysis. Therm mean heat, indirectly measurement of the temperature. The instrumentation continue. This figure display another block diagram of DMA instrument. In this, the clamp, the sample is placed. This is driveshaft. There is up and down of the instrumentation shaft to move the sample and up and down. This is suspension, the driven motor, LVDT, stepper motor, and the carriage. The figure displays the important components of the DMA, including the motor and driveshaft used to apply torsional stress, as well as the linear variable differential transfer LVDT used to measure the linear displacement, mean the movement of the sample. This is the dynamic is the movement measured in way of displacement. The carriage contains the sample and is typically enveloped by a furnace and a heat sink. Now we discuss about the types of DMA analyzers. The DMA can be either stress or strain controlled. If we use the stress controlled analyzer, in stress controlled analyzers, move the probe a certain distance and measure the stress applied. while in case of strain control analyzer provide a constant deformation of the sample. In DM analyzer can also be applied stress or strain in two manners, axial or torsion deformation. The main types of analyzers are stress control or strain control. When DM analyzer we can use stress and strain way, then it's further subclassified in two ways. These two ways are the deformation, and deformation may be axial or the torsional deformation. Now we'll discuss the axial analyzer. That is, by applying this analyzer, we will get the axial deformation of the sample under investigation in DMA instrument. In axial analyzer applies a linear force to the sample and is typically used for solid and semi-solid material to test flex, tensile strength and compression. Axial instrument should not be used for fluid sample with viscosity below 500 Pascal second. This is a typical presentation of force applied axially and force applied torsionally. On the left side of the diagram, you can see the force applied axially, that is vertical force, while the right side the force applied torsionally by side. Torsionally means the force applied by side way. In case of torsional analyzer applies force in twisting motion. This type of analysis is used for liquid and polymer melt, but can also be applied to solid. Torsional analyzer cannot handle material with high modulus. Now, what kind of sample to be tested by DMA? DMA thermoanalytical techniques, as the technique developed more and more features, were added, such as the ability to test samples in different forms, solid, liquid, paste, etc., in different mode, tension, shear, bending, torsion, and also in different environments. The environment may be air, liquid range of humidity, etc. Different fixtures can be used to hold the sample in place and should be chosen according to type of the sample analyzed. These three factors mean its form, its mode, and in different environment. This depends upon the type of sample which we want to analyze by DMA technique. Now, different types of sample holders are used in DMA analysis. These are called the DNA geometries, DMA geometries. In DMA geometries, double cantilever. In double cantilever, you can see from the picture, there is a actuator, clamps and sample. Sample is placed between the actuator and the clamps is holding the sample. That is called the double cantilever. There is also a single cantilever is used for sample holding in DMA analysis. In DMA geometry, single cantilever is presented in this figure. Again, the actuator, clamps, and the sample is held between the clamps and actuators. Now, this is another way of sample holder in DMA technique, DMA geometry. This is called the 3-point bend. In 3-point bend, actuator is placed above the sample, while the supports are provided down the sample. Mean the sample is between the actuator and the support. This type of called DMA analysis is 3-point bend analysis, and this is holding type. This type of sample holding is 3-point bend. What is the specialty of DMA technique over the other thermoanalytical techniques? Mean DSC, differential scanning calorimetry, or TGA, differential thermogravimetric analysis. What is the specialty of this technique? Although DMA can be used to investigate many physical properties of material, but its key strength is the evaluation of glass transition temperature of the polymer. The DMA sensitivity for the TG make it preferred tool for scientists around the world. Not only can DMA accurately measure TG, it can also successfully identify secondary transition which have a significant impact on the performance of the polymeric material. Now we will discuss about some features like operation of DMA instrument. In the operation of DMA, in standard use, the basic operation of DMA involves the application of sinusoidal varying stress to a sample and the monitoring of the resulting deformation. In typical DMA experiment, the stress is applied at a constant frequency, usually 1 Hz. The strain is kept constant and the temperature is increased at a constant heating rate, typically between 1 and 5 degree centigrade per minute. Basically, this is the temperature span during the analysis of any material by using DMA technique. So, what kind of output we will get after analyze the sample by DMA? The output from DMA unit is in the form of key mechanical properties, that is storage modulus E dash या E prime, loss modulus E double dash E prime E double prime, and a measures of damping or loss tangent versus temperature or time. On some DMA machine, the coefficient of thermal expansion can be measured as the expansion or contraction of the sample is measured. This is a DMA scan. In this, storage modulus is presented by a type turquoise line. Loss modulus is represented by a red line, while the tangent delta is presented by a green line. This is the data of a polymer after getting our of output when any type of polymer comes under observation in DMA instrument. Different regions are obtained, that is the glossy zone, gloss transition zone, rubbery plateau, and melt flow zones. How we get the accurately data from the DMA accuracy of the DMA data? Although it can be sometimes challenging to obtain the accurate mechanical data using a DMA, the main purpose of technique has always been to compare a series of tests using the same sample size and test conditions. Aspects of material formulation and processing condition can then be varied and impact on the physical performance of material studies. Again, this is a DMA thermal scan. It is another type of DMA scan that get by DMA instrument of any polymer under investigation. This is again a temperature, storage modulus, loss modulus ratio, draw against the temperature, and on the other side we will get the tangent delta. Again, the storage modulus, loss modulus, and tangent delta is shown in this graphical explanation. Now about the output data, we will discuss various terminology that is obtained in output data of DMA. That is storage modulus E prime, a measure of the elastic response of a material, but not the same as Young's modulus, also called the in-phase component. Young's modulus, the ratio of strain when an increased stress is applied to a sample. Loss modulus E double dash or E double prime, a measure of the viscous response of a material, also called the imaginary modulus or out of phase component. Damping or loss tangent. Damping is the dissipation of energy in the material under cyclic load. It is a measure of how well a material can get rid of energy and is reported as tangent of a phase angle. It tells us how good the material will be at absorbing energy. It varies with the state of material, its temperature, and the frequency. It depends upon the operating parameter, mean temperature, or the frequency. Now, in the former slide, we have discussed various zones when a polymer is under investigation in DMA, and DMA thermal scan is presented in this slide. So we will get different types of regions of viscoelastic behavior of the polymer when this is under investigation in DMA technique or DMA methodology or DMA instrument. For example, first of all, we discuss the glassy zone. Sample is hard, springy, or rock-like. Bending and stretching of bonds is occurring. Tangent delta is below 0.01 and it is below the TG. TG is crystallization temperature. So in glassy zone, you can see the green tangent delta that is less than 0.01, while in glassy zone you can see the storage modulus and the loss modulus at the high side of the tangent delta. Now we discuss the Sanckert zone. That the Sanckert zone is glass transition zone. In glass transition zone, sample become less hot as storage modulus decrease and tangent delta peak increases. It's very clear from the figure. The sample storage modulus decrease, the tangent delta increase. The storage modulus is of a blue color. Thus, in this region, can clearly seen it is toward the decreasing point, while the tangent delta is toward the increasing point. Tangent delta peak height is typically between 1.5 and 2.0. The onset can be taken as the transition temperature. The onset start of anything usually in a bad manner. The Tg is the transition temperature, glass transition temperature. Now, number 3 zone is in DM thermal scan is rubbery plateau. Sample is springly. Main backbone chain exhibit gradual slippage. Tangent delta is near 0.25. In 3 zone, again the tangent delta is decreased, and in this case all the 3 parameters decrease, but the tangent delta is all among 3 parameters in the lesser stage, while the loss modulus is the middle of between the storage modulus and the tangent delta, while the storage modulus as the top of in this zone among 3 parameters calculated by DMA technique for the polymer under investigation. Now the 4th one in DMA thermal scan is melt flow zone. The sample is flowing water-like, free chain movement and interchain slipping occurs. Tangent delta is much higher than 1.0. This is above the TM in crystalline material. TM is a melting temperature, often treated as part of a viscous region. In the 4th region, you can see all 3 parameters. Now in this zone, that is melt flow zone, the tangent delta is at the top, while the storage modulus is the lower one, and the loss modulus is between these 3 parameters. Now we will discuss the various applications of DMA technique. In the DMA technique, we can determine the glass transition temperature. This glass transition temperature has already been discussed in former thermoanalytical techniques. In this DMA, we can also determine the glass transition temperature of any polymer under investigation. In case of glass transition determination, the glass transition is seen as a large drop a decade or more in the storage modulus when viewed on a log scale against a linear temperature scale shown in this figure. A concurrent peak in the tangent delta is also seen. The value reported as the tangent varies with industry with the onset of the E drop. The peak of the tangent delta and the peak of E prime curve the most commonly used. Now, we already been discussed the E prime and E double prime. In this figure, you can see the modulus drawn against the temperature, and the other side is a tangent. From the graph, you can see the line, blue line, that is onset E prime 133.1 degrees centigrade, peak E double prime 136.7 degrees centigrade, onset E double prime 127.3 degrees centigrade, onset tangent is equal to 130 degrees centigrade, and peak tangent delta is equal to 140.5 degrees centigrade. So tangent this tangent delta at 140.5 degrees centigrade tells about the glass transition temperature of any polymer under investigation. This is another application of the DMA, curring of the material. DMA is commonly used to study curring of material, as this process involved a dramatic increase in the modulus value. Again, the modulus value, loss modulus value is E single prime and E double prime. It is commonly used to get both the point of gelation and the point of vitrification for thermosetting material. Thermosetting material already been discussed. The thermosetting material become hardened and softened with the applying the different type of temperature without change their chemistry, without change in their properties. They become hardened, they become softened variably. Currying can be studied with temperature ramps and isothermally at a fixed time. Isothermally means when we make the temperature constant and run the DMA instrument for the analysis of the polymer. This is another application for humidity studies. You can study different type of polymer, different type of materials under different humidity conditions. There are humidity controllers are in different DMA machines are placed that control the humidity. Humidity study is known to be tremendous effect on the properties of material from polymers to paper to natural product. Humidity play an important on the life of the different type of material that are already in explained polymer. Humidity affect the polymer, humidity affect the paper, or humidity affect the various natural products. If the humidity increase, mean temperature content of that particular material will be increased. With the increase of the temperature, water content of that particular material, there is a chance of spoilage of that particular material, especially in case of foods. But in case of food, if the temperature, water content of increase, the spoilage will be easy, and the bacterial growth that and this is vulnerable to different macrobiological growth. The macrobiological growth may be a bacterial growth or maybe a fungus growth, and it's a damaging of food, and a damaging of the economy. The DMA instrument has the option of being configured with the integrated humidity generator that allows precise control of the humidity in the furnace. As in the former slide, we discussed the instrumentation of DMA technique. There is a furnace place in which the sample is placed. That furnace of DMA instrument is connected with humidity generator at various levels of humidity. The properties of the material can be generated, either it is spoiled or not spoiled, either it is damaging or not damaging, and at what level of humidity it is on the safe side for the storage, for the transportation of a particular material. This permit and precise studies on how humidity affects the properties of your material. As well as the most standard use of the DMA to measure polymeric sample, they have been employed to directly measure the physical changes of the material in some unusual environments. For example, the flexibility of some DMA machines allow the mechanical measuring part of the unit to be embossed in liquids, which allow for some interesting application. These includes the flexibility of some DMA machines allow the mechanical measuring part of units to be embossed in a liquid, which allow for some interesting applications. These include the measurement of a sample of human hair immersed in shampoo in order to monitor the storage modulus. This is particularly important when new chemicals are used, which could potentially have an adverse effect on the properties. This is an R&D type of activity where when any company that is related to the cosmetic want to introduce a new shampoo with new materials, then these shampoos are ultimately used for the human hairs. Then human hairs storage and immersed in shampoo, and the response of the particular shampoo that is under investigation, that is to be launched in the market, the its damaging effect or beneficial effect, the advantage to the human hairs is monitored, and it elaborate if the benefits or drawbacks of using the new shampoo before coming to the market. The measurement of the food stuff, such as the direct measurement of melting of chocolate or frying of potato chips at different temperatures and in different environments, such as cooking oil. This is also very important application. The melting of chocolate. So usually you see in the market the chocolate at ordinary temperature become melt. So they discuss various at various temperatures. At various temperatures, stability of chocolate in different kinds of chocolate products. Either it is melt or not melt. Not in Pakistan, usually the chocolate of bad quality is produced, even in the best quality chocolate coming from the Germany and in the European region. Because these companies have advanced analytical lab where these thermoanalytical technologies involved to check the stability of the chocolates, even if it's bad quality or worse quality, and on what temperature and how many temperature it there and will be stable and at what level of temperature. Also, this is another application of frying of potato chips with different temperature, and different temperature mean the and different environment. For example, using a cooking oil or a ghee for frying the chips or any other kind of frying material. If the temperature is very high, then there is a free radical reaction become in the fats. This free radical reaction can produce different types of byproducts in the oils and the ghee, and these type of metals can be attached with the potato chips or another kind of material that is under frying or under observation. So DMA technique is also versatility to check the effects of temperature under different environments for the potato or any other kind of material. If there is any byproduct is formed or any other material form that may be agglomerate with the end product, this can be determined by using DMA technique. Not by this type of product can be uh, determined, can be utilized, can be analyzed after hyphenation of DMA with other type of material or other type of analytical instrument like FTIR, gas chromatography, and so and so. So this is also an important application of DMA in food science and food materials. So thank you very much to attend this seminar, this lecture on DMA and on DMA. If anybody have a question, then you can put the question in the chat box. I will answer every question. So be tentative, and thank you very much again, and God bless you in this